Okay, coming back from the course of hydraulics, okay, to engineering profession, okay, but hydraulics is much more interesting, right? So we have gone through the syllabus. We have discussed what are the items which are included in a profession, okay. So we have knowledge, we have skill, we have training, we have, and there are some bodies involved. We will talk about them today as well. You need to go through examination. You should be doing something which is good for the society. You are expecting higher salaries. I told you earlier as well. Don't expect it for the first 2-3 years of a career. Okay, higher salary when your kids are born. Okay, and you have to follow some legal and ethical requirements. Okay, so you have to behave in a proper manner. And engineering profession, you have to solve a problem. The problem should be related to science and technology. You have to think logically. Okay, reason, fitness. Okay, that this item is good for this guy, but the same item will not be good for the other guy. Okay, the reasons, logic, and you have to do it in a systematic way. You have to show the calculations. You have to go through the procedure and so on. Okay, when you are doing these things, you may end up with a product, process, method, whatever. But you have to take care of 3 aspects: safety, reliability, and cost. And the problem is you have to make a balance. If you try to increase safety, it may increase the cost as well, which you don't want, right? You have to increase safety, but at the same time keep the cost at some optimum level. Then this is the list of engineering skills. Knowledge, which the teacher is trying to give. Learning is what you do. Exam, what we take. Training, which is part of your plan, where you go in the work environment and you see what is happening. Okay? Even in training, somebody is guiding you. Training means somebody, you go in the work environment, but there is a supervisor over you who is telling you what to do. Then you get to experience, which comes after your graduation. Okay? So in this, you are alone now. You are expected to do it yourself. Nobody will tell you what to do. Okay? You are hired, but you have to do it yourself. Clear? Okay? You have to have ability as well to perform, not just have it in your mind. A very common problem I have heard from students: I know everything, but when I go to the exam, I cannot do it properly. I feel pressure, I am under stress, and so on. Okay? I know some good students who have this problem. Okay? So this is not the problem of knowledge and learning. They know it. I know they know it. But when I see their exam paper, I cannot give even 10% marks. Okay? So this is not because of their knowledge or learning, this is because of their ability. Okay? You must be able to do it as well. Just knowing it is not enough. Okay. And then you have something extra which we call as the growth. Okay. Again, it is part of your study as well as part of your career. So even after graduation, you have to continue the growth. Okay. And growth is related to something extra, not part of your job. Okay. So you get your job and you go there 9 to 5, you are doing the same thing as everybody else. So you will be stuck there like everybody else. You want to go higher, you have to grow yourself. Okay? So you go to the site, you manage site, and that's it. You will become, or you will remain a site engineer for the rest of your life. But now you want to become a manager. So maybe you have to get some extra certification. Maybe learn some new software. Okay, do something extra. Okay? This is called, or this is part of your growth. Okay, so we talked that engineering skills are divided into 2 categories, right? Which 2 categories? Hard skills and soft skills. Okay. Now when we take exam, you're writing exam. It is an exam of hard skill or soft skill? hard skill, right? Because exams are hard. They are for hard skill, right? They must be hard. Agreed? Everybody agreed? Okay. What about presentation? Hard? Is it for hard skills or soft skills? Soft skills, right? It's for soft skills. It's soft, not hard. You were explaining her hydraulics, which I don't even understand. How can a presentation be hard? It's not more than this. Yes. So when you come for presentation, just look at her. Easy. This course is not about presentation, but this is a trick. Okay. You look at your friend. Make sure the friend is not. I was giving a presentation in my university, and one of my friends was constantly talking throughout the presentation. Okay. And I told him to leave the room in front of the teacher. And he was angry at me. Why did you tell me this? I'm your friend. I told him, if you are my friend, who needs enemy? You are the one who is disturbing me. Okay, so she is not like that. Right? She is not disturbing, right? Let's look at her and do your presentation. Okay. So anyway, we went through these skills. Okay. Now we come to another aspect which is related to engineering, which is the difference between science and engineering. Okay. As an engineer, okay, we are dealing with science. Agreed? As an engineer, we deal with science, right? Okay. You also take some science courses. You have taken in school, you have taken in university as well, right? Okay. What's the difference between science and engineering? Like, what is the difference between science and engineering? Huh? Discovering the law, and engineering is applying the law. Okay. Science is discovering the law, engineering is applying the law. Anything else?
Engineer more professional.
Engineer is
More professional.
more professional. Okay. And scientists are less, huh? I think. Okay. I have some friends in the science college, I will tell them.
No.
Yeah, it's good. I'm more professional. Okay, anybody else? Yes. Anybody else? Okay. Okay, the first point here is what she already mentioned, that it's the application of scientific principles, okay, and mathematical methods. So math is also part of science. Math is also a part of science, okay. So you apply the principles. For example, somebody told us about gravity, right? There is a force which is called as a gravitational force. Okay. So now you use this force when you are designing your structure. You have to consider it when you are designing your structure. Okay. Because you know that because of this force, something or somebody can fall, right? Okay. So now you have to consider it in your design. Okay. And when you are doing so, you have to perform your own calculations as well. So some mathematics is also involved. Got it? Okay. But you are applying it. You are not discovering a new law. Okay. You are not making a new equation. You are using the laws and equations which are already there, the models which are already there. Okay. Why do you apply it? You want to apply it to design something. Okay. So we design things which are already existing. We're designing a building, right? Building is not something new. Huh? We design a villa, we design a shopping mall. We have shopping malls and villas, right? It's not something new. Okay? So you design it and it's part of engineering. Okay? I'm designing something which somebody else has already done in the past. Okay? Or you may create something which is not there. Okay? By applying the scientific laws and principles and methods, you create something new. Okay? For example, you may create a new fuel. Now we have electric vehicles, right? They work on, they run on current. Okay? They charge like your phone and they run. Okay? Somebody must have thought about it, right? There was a person who said, okay, we can run a vehicle on electricity as well, right? So what was he doing? He was creating something new, right? Clear or not? Clear? I always ask the person who just entered the room, and they always say yes, very clear. Okay. So they may create something new, which is not there. So designing a thing which was already there, creating something which is not there. Okay. And then we have something which is optimization. We are not creating anything new. We are not constructing anything. We are just trying to manage the things which are already there. Okay? I'll give you a very simple and obvious example. Okay? You have your timetables, right? Your schedule, course schedule. And everybody has their own problems, right? With the schedule. I have conflict here, I have conflict there. If I take this section, I have to wait for 2 hours. If I take this section, then I cannot go with my friend. Serious problems, right? Very serious problems. Okay? So if somebody comes up and he designs a system to manage this timetable. Okay? So everybody becomes happy. Not possible, right? But let's say somebody does that. Okay? Is he designing or creating something new? Is he designing a structure? No. He's just managing the resources which you already have. The same teachers, the same classes, the same students, same courses. But now he is managing them in a better way. Okay? So this is called as optimization. Okay? So he's taking the things which are already there and he's trying to make the best use of it. The best use of them. Okay? So you will see there are some courses in your degree plan which are related to design, and there are some courses which are related to management, construction management, traffic management. Okay? So both these are part of your curriculum. Creativity is mentioned here, we cannot teach you. We cannot teach you to be creative. I asked the question, what is engineering? In the first lecture, somebody wrote creativity. Was it one of you? No? That question is gone, right? So somebody wrote creativity. We cannot teach you creativity. You have to be creative on your own. Okay? Think about something new on your own. We cannot teach you. Nobody can teach you, right? Nobody can teach you to be creative. Okay. So in engineering, we emphasize on problem solving, design, and innovation. In science, what do we do? Okay, so there we are applying. Here we are studying. Okay, you see the main difference now? Applying and studying. Okay, so it's like the lecture and the exam, right? What is the lecture? Study, right? The lecture is like science. An exam is like engineering. You apply. Okay, valid. Clear? Okay. So what are we studying? They are studying, or what are they studying? They are not studying. What are they studying? Structure and behavior of physical and natural world through observation and experimentation. Okay. There is a word written here under science, which we have discussed for engineering as well earlier, and I showed it to you today as well. Can you pick that word? It is under science here. That word is mentioned under science here. but we discussed it for engineering as well. Anyone? And there are only 2 sentences under science, right? And we are only discussing the first one. What is the first? What is the word in the first sentence about science which we have discussed for engineering as well? Huh? Structure? No. No. Something else. Huh? Experimentation. Do we do experimentation in engineering? We can do experimentation in science, but not in engineering. We shouldn't. If you are doing experimentation, you are still doing science. Experiment means what? Let me try this and see what happens, right? This is science.
Systematic.
Systematic.
Engineer system also.
Yes. Both science and engineering are systematic. They are different things. Studying and designing, different things. But both have to follow a system. Right? Okay. So for example, we know the gravity for Earth, right? What is the value of gravity for Earth? 9.8, right? Huh? Somebody gave it to us, right? When they gave it to us, they did their study. Okay. What is the gravity of Moon? Huh? What is the gravity at Moon?
They can put.
Take 100. Search for. Where? Search for. Huh? 1.6. 1.6? Both of you? 1.6? 1.6? Huh? But you thought it was 100, right? Huh? What if I believe you? What if I believe you and started designing my structure for you? Okay? So the point was, when scientists come with a conclusion, they come with a result. It's not based upon opinion and judgment and want and desire. Even for that value, 9.81, they must have done their study. They must have done their calculation. Okay? Same thing for the gravity on Moon. Okay? 9.8 is very, very common, right? Everybody knows it. It's a constant, right? Okay? But you didn't know about Moon, so you have to search for it, right? Okay? And then you started searching for it, somebody gave me an answer. Should I take that answer? No, I have to verify it, right? I have to verify if the answer is correct or not. Okay? So this verification is also part of systematic study. Okay? You searched on what? Where did you search for it? Google? Huh? In the other section they were using ChatGPT to search for this. Okay? Anyway. So you have to use some method to check the validity of your result. That my result is accurate, it is correct. Okay? And that method comes under systematic study. Okay? Clear or not? Huh? Somebody takes a piece of wood from this table. Okay? And they go and test it in the lab for strength. Okay? And they take a piece of steel and do the same test on that piece as well. And they find the strength of wood is higher, steel strength is lower. They have the result. They are showing it to me. Now tell me, what is stronger, steel or wood? Steel is stronger, right? But what do you do with this guy? Put him in the mental hospital? What do I do with this guy? He's saying I tested both of them. What do we do with it? Huh? He's proving it. He's saying that, see, I tested in the lab, this is the result. Now what do I do? Nothing, right? So, one more important part of scientific study is to repeat. Okay, maybe that steel was defective, but it was not good. Okay, maybe it had corroded. Okay, because of water or something. It was already damaged. That's why strength was good. Now you have to repeat the same experiment again to prove. Yes, you have to prove, yes. But one proof is not enough. You have to repeat and make sure that you always get the same result. Only then you can give me the answer. Got it? So this is all part of systematic study. So you study the structure as well as the behavior. Okay? Behavior means what? Properties. Behavior means properties. Okay? So we have different gases, right? We have oxygen, carbon dioxide, right? You know about oxygen, carbon dioxide. Okay? You know it, right? Which one catches fire quickly? Oxygen or carbon dioxide? Huh? Oxygen catches fire quickly. Okay? That's a fact. Okay? So, what is this now? This is behavior of oxygen. When this happens, then it will do this. This is behavior. Okay? And this can be done through observation or through experimentation. Observation is I see something and I say this thing is like this. Observation, I just see it. Observe. Maybe see it with a microscope, maybe. But just by looking at it. Okay? Okay, so I know the chair cover is pink. I'm just looking at it. Okay? Experiment is you take a sample and you do something with it to see what happens. This is experimentation. Okay? So observation is just looking. Experimentation is doing something with it. Okay? So here our focus was on problem solving, design and innovation in engineering. In science, our focus is on understanding. Okay? Here our focus is to understand why this thing is happening in this way. Just to understand. Okay? So if you understand something but don't do anything with it, it is science. You understand something and then you design using that knowledge, that is called engineering. Okay? Clear? So I told you oxygen catches fire, right? Now you know it, right? Now this is what? Science or engineering? This is science. Okay, now you make a system which will use this property of oxygen to light fire. Okay, this will become engineering. You make a new stove or new oven or something. This will become engineering. Got it? Okay. So when you know oxygen catches fire, this is science. You use oxygen to make something that will make fire. That is engineering. Got it? Clear? So science is focused on this one. So here we are focusing on application and practical solution, and science is we are trying to study and understand. Okay, now you look at the first sentence and it includes the things which we already said before. Okay, except one thing extra. What is the one thing extra in the first sentence, in the first point? We were discussing science and engineering, right? We have discussed all these things, but there's one extra item here. What is that extra item? In the first point. It is in the first point. Huh? Science and mathematics? No, it was. Huh? Devices. We discussed. Huh? Solving problem, we mentioned it. Solving problem, we mentioned it. Create new systems, we mentioned it.
You mentioned just system, so create new
No,
system.
create. No, everything else is mentioned, just one thing. Should become very obvious, right? Okay, all of you did the wrong things, so now she can get to the right answer. Okay. Benefit to the, you said it? Sorry. You were saying devices to benefit. Focus on devices.
Products.
Product. Same thing. Anyway, the important thing which I want to focus here is benefit to civilization. Okay? In science, you are trying to understand things, whether they will benefit you in the end or not. You know lots of things from TikTok and Instagram, right? Do they benefit you in the exam? No. Okay? So, waste less time here. Okay? But the thing is, in engineering, we are looking at the society. How can I use this to benefit the mankind, the civilization, the society? Okay. In science, they are focusing on learning something new. If I learn something new, my objective is finished. If I learn something new, then I have achieved something. But engineer will not stop there. He will go forward with this new knowledge and see how he can use it for the society. And he will try to create something for the society. When that is done, then the engineering outcome is achieved. Okay? The mission of science is to learn something. The mission of engineering is to do something for the society. Got it? Okay? Okay. I want you to do one more search. What is the meaning of ABET? Search for it. ABET. Yes, what does it mean?
To help someone do something wrong.
ABET?
Help someone.
This thing?
Yes.
Okay, anybody else? I didn't know that. Yeah.
Accreditation board for
See, Accreditation Board for
engineering and technology.
Engineering and Technology. Okay. Accreditation Board for Engineering and Technology. Okay, so this is a board because of which all of you are in trouble. Okay, but this is a board which gives us guidelines for teaching engineering. Okay, so almost all universities which are in the Gulf region, and they are giving the degrees from the higher education of the Gulf. Okay, they are accredited or they have the membership or certification of ABET. So these guys come and tell us how many courses you should have from science, how many courses you can have from other fields. We have courses in history and so on and so forth, right? So they tell us how many courses from those fields and how many courses from engineering, common engineering, civil engineering, when you should do the senior project, when you should have the junior project. We don't have junior project now, but if there was a junior project, so you understand now, right? So these guys, they tell us what to do with you. Okay, and their standards or guidelines for teaching engineering are followed in many countries. Okay, I already gave you the example of the Gulf. Most of the Gulf universities in Gulf are following that. Okay, so what are they saying about engineering? Okay, so Can you read it? What are they saying for engineering? What is engineering according to them? A profession in which the knowledge of math, science, gained by study, experience, practice is applied with judgment to develop ways to utilize economically the materials and forces of nature for the benefit of mankind. Okay. So all the points which we have discussed earlier, now they combine them together. We said what? You have to apply science and maths, right? It's mentioned here, right? You have to get that knowledge by study, experience and practice. We said it at the start, the previous lectures. You have to utilize this knowledge. How? Economical, right? Okay. So you can have the best system, which is the most expensive system in the world. Nobody will use it, right? Okay. And why are we doing it? Okay. So they are focusing on these three aspects. One is what you are using. So science, maths, and so on. How you will get it? You have to get it through study, experience, and training. And why will you apply it? For the benefit of the mankind. Okay. This is according to them. Okay. Before we move forward, let us do one activity. Okay. I'll go one by one, each person. Okay. So we're discussing science and engineering, right? I'll go one by one, each person. Okay. So I'll start from him, and he will tell me a field or a course in engineering. The next one will tell me a field or a course from science, then engineering, then science. Okay? Clear? You can use Google, Chat, GPT, whatever. No problem. Okay? But you have to tell me, and you cannot repeat. Somebody says X engineering, you cannot say the same thing. Okay? You cannot repeat. Is it science or engineering? Engineering, science. Chemistry, yes. Engineering. Computer programming, yes. Physics. Engineering. Huh? Statics. Okay. Mathematics. You are doing what? Engineering. Science. Engineering, yes. Now what do you say? Architecture. You have to think. Okay. They were part of engineering, but now they are not. Okay. Huh? Stat means what? In statistics? Is this science or engineering? Science. Okay. Civil. Science, yes, science. Bio? Okay, biology, yes. Engineering. Is that what? Give me a field in engineering. A field or a course. Should be very easy, right? Huh? Nothing outside. There is no such thing like that. Anybody can be engineering design, right? What did we do? What did we cover in civil engineering? Civil engineering, highway construction, and so on and so forth. Give me something like this. Huh? Architecture already covered. Huh? Clear what? Don't look at her. She's giving you wrong answer. She's not your friend. Huh? Mechanics? So, the three of you will be in different rooms at that time. Okay. But this should have been easy. We have mechanical engineering, electrical engineering, electronics engineering. There are so many fields in UOB. Okay? It should be easy. Anyways. Okay. So I told you, ABET gives certification and accreditation, right? Okay. To who? Universities, right? This is a board or a council which gives certification to engineers, not universities, engineers, professionals. When you go in the field, you can get certification from National Council of what engineering examiners. Okay, so they have a council which gives certification to engineers. So let us read what they are saying about engineers. The previous definition was for engineering. This is for engineers. Okay, go through it. Read it. Read it. Read it. Done? Okay, now tell me what is common between this definition and the definition of engineering. What are the common things here? I showed you the definition of engineering, right? So what is common between that definition and this one? The ABET definition and this one. What is common? Yes. Knowledge and use of science. Okay. Engineering has it and this one has it as well. Okay, anything else? Analysis and design, yes. Engineering involves it, engineer has to do it. What else? Both of them need practice? Very good. Practice? Ah, okay, practice. Okay. Anything else? Hmm? Any other common feature here? Hmm? He is saying practice. Okay, he is focusing on the word. But this is also common, right? The ABET says that for engineering, the knowledge has to come through these things. According to ABET, to get the knowledge of science and maths, you have to study and you have to train and so on and so forth. Okay, clear? So after you get the knowledge, you should be able to do what? Practice. Okay, so we practice. That's not a real thing, huh? We practice like you practice for the match, right? You just practice. Huh? It's not like anything goes wrong and they come to you and you say, I was just practicing. Okay, it doesn't work like this. Okay, practice means now you can do it on your own. Okay, you can do it on your own, and you are studying, and when you are training, somebody is telling you. But when you go for practice, practicing the profession means now I'll do it myself. Clear? Another definition of engineering, so a person who will combine science, mathematics and economics, okay, to solve problems which are faced by the society. Okay, something different. Okay, so this is another definition. Engineer who will combine these fields to solve problems. Okay, what fields we are combining? Science, math and economics. Okay, why economics? Why economics? Cost, right? Okay, as I said, you cannot solve the problem of the society if you don't consider the cost. I have a car which flies. Okay, and you say I have solved the problem of traffic in the whole world. Okay, and that car is 1 million BD. They have solved the problem of maybe Elon Musk. not my problem. Okay? Until now I don't have like 1 million PD, right? We'll get it sometime inshallah. Until that car is not for me, right? So that's why economics. Okay? And that's why you have the course of economics, right? There's a course of economics in your study plan, right? Which course is that? Huh? Quantity also deals with economics, but there's a course of economics. 6 semester, right? 300 something.
Yes.
And it's not CN.
No, bench.
Mensch. Huh? Mensch is from who?
Business center.
No. Huh? It's from who? Who teaches that course? Which department? No. No. Mensch to management, huh?
Not business center.
No. Yes. Okay. I don't know why. But this is how it is. Mechanical department. Mechanical engineering. Okay. Okay, so engineer converts scientific theory into useful applications and provides for material needs and well-being of people. Okay, so engineers may give something to a society which they need. They may give something which just improves their lifestyle. Okay, there are things we need and there are things we want, right? Okay, so like you guys, everybody wants an A grade, right? Do you need an A grade? Huh? Yes? No, you can live without an A as well, no problem. You will live, like you have lived in the other courses, right? Okay, so you don't need an A. I don't need to give you an A, right? Okay? You may get an A, no problem. But you don't need it, okay? Give me an example of a need which is solved by engineers. Need. Things which an engineer gives to the society which they need. Yes. So many of them. Buildings, right? A house is a need, right? A house is a need. Okay, so engineers provide, right? Give me example of something which just improves the lifestyle. You don't need it, but if you have it, it's good for you. And it is given by engineers. Tell me. Again, so many of them.
Skills.
Huh?
Skills.
Skills?
Yes.
Something
Skills.
like something. Give me something like a thing which improves your life, but you don't need it. Who needs a right? In a sense, okay, fine. I took this answer from the other section as well. I don't know why you guys keep on giving answers from. You are saying highways, you are saying transportation. You guys don't think much about transportation, right? But in a way, yes, you can live without transportation. Okay? You get the idea. Okay? If you don't have, for example, a car, you will live. You will walk. But if you have a car, it makes it better, right? You don't have a street, so your car moves on sand and so on, uneven ground. It can move, but if you have a road, a proper street, it is better, right? So these are needs and so on, things which improve your well-being. Okay, we will stop here now.